Hello students. So now in this lecture we're gonna start with a fresh and a new chapter and very interesting beautiful chapter which is known as application of derivative. So this is a chapter number 4 from Max 1, as this is a very important chapter as board point of view, as well as the weightage of the chapter compared to other chapters of Max 1 and Max 2. The weightage and the marks, it is more. So that's why this chapter, it is one of the important chapter from Max 1. As the names, when you will see the name of the chapter, it says that it is application of derivatives. Application of derivative, in simple language I will say, it is extent part of the derivative. So when I say the extent part of the derivative, so it means without knowing the basic concept of a derivative, without knowing the basic formulas of derivative, you cannot able to solve the sums of this chapter. Yes, of course, the name of the chapter says that applications of derivative. So without knowing the concept, basic things like what is the formula for x raised to n, what is the formula derivative of x, what is the derivative of sine, what is the derivative of cos, if you don't know the basic things, of course you will end up with the difficulties in this chapter, because it is the extend part. So when I say it is the extend part of the derivative, so you must know all the basic things, the basic properties, the basic concept of your previous chapter, that is chapter number 3, as this is chapter number 4 from Max 1. I hope you all might be knowing the basic concept, all the formulas, the derivative of x raised to n, derivative of x, derivative of uh, sine, derivative of cos. I hope you all might be knowing the properties also, the rules also, addition, subtraction, multiplication, division, yes or no? Okay, I hope you all might be knowing all the things. So just I will explain the summary of this chapter, what all things we have to learn in this chapter, and just a basic thing I will explain about the derivative, not all the concept, as in this chapter we will be using the concept, the formulas of derivative, of course the properties, the rules also, not all the properties, the just a basic things, so that I will explain what all things of derivative we will be using here, the concept, the rules. Okay, so before that we'll see the summary of this chapter, what all things we have to cover in this chapter number 4. As the chapter number 4 contain 4 exercise. Your first exercise, it is based on to find the equation of tangent and equation of normal. The second exercise, it is based on increasing and decreasing function. Your third exercise, it is based on maxima and minima. And your fourth exercise, it is based on applications of derivatives in economic. So as this chapter is divided into 4 group, I can say the first exercise, it is based on equation of tangent and equation of normal. Second exercise, it is based on increasing and decreasing function. Third exercise, it is based on maxima and minima, and the last exercise, it is based on applications of derivatives in economics. So here today we're gonna start with the first exercise, in which you will be seeing how to find the equation of tangent and equation of normal. Before that, we'll see some basic things and the basic concept of derivative, as well as the basic things of coordinate geometry, which was there in 9th and 10th standard. Okay, so I hope you all might be knowing the formula, derivative of x raised to n. So what is derivative of x raised to n? It is n into x raised to n minus 1. I hope you all might be knowing. So derivative of x, what is the derivative of x? Yeah, nothing is there, so we can take 1, apply the formula, yes or no? So here the derivative of x is what? 1, yes or no? Okay, you must know the basic concept, not all the formulas, not all the rules. Okay, just the basic formula, like derivative of x raised to n is what, derivative of x is what. If I say derivative of y, we used to write y, derivative of y as dy by dx, yes or no? Suppose if you want to find derivative of x cube, so can I say x cube, derivative of x cube, it look like what, x raised to n, apply the formula, so the answer will be what, 3 into x raised to 3 minus 1. So here the final answer will be what, 3 into x raised to 3 minus 1 is what, 2. So here we got the answer 3x square. Suppose this x is replaced by y cube. Again I can say this look like what, x raised to n only, yes or no? Apply the formula x raised to n. So the answer will be what, n into x raised to n minus 1, yes or no? But here x is replaced by what, y. So apply the chain rule. So chain rule will be what, d upon dx of y, yes or no? So here the final result for y cube will be what, 3 into y square into dy by dx. Just remember, whenever you have to find the derivative of y, it will be dy by dx, and whenever you have to find derivative of y square, y cube, apply the chain rule. As for y square, it will be what, apply x raised to n, so you will get n into x raised to n minus 1, but here x is replaced by y, so here we'll apply the chain rule. As per the chain rule, this is the concept. I hope you all might be knowing the chain rule also. So 2 into y, 2 minus 1 is 1, so no need of writing here 1, because the without the power, without writing the 1 also, it is 1 only, yes or no? And here this will be what, dy by dx. So remember, whenever you have to find derivative of y, it will be dy by dx. Whenever you have to find y square, y cube, you have to apply chain rule. Okay, as here x is replaced by what, y. For this, as there it was x only, so directly we had applied the formula of x raised to n. But remember, if x is replaced by y, you have to apply the chain rule. So these are the basic things which you have to remember while solving the derivatives. Okay, now that was a point number one here, I can say. The second point is what, I hope you all might be knowing the formula, slope point form, yes or no? Slope point form. So what was the slope point form? I guess you had studied in 10th standard in coordinate geometry. It was y minus y1 equals to m x minus x1. It means, what do you mean by slope point form? If you want to find the equation with respect to slope point form, it means slope means here it is known as m, and point means here it is known as x1 comma y1. When a line is passing through a point x1 comma y1 having a slope m, so its equation is y minus y1 equal to m x minus x1. That was the formula. I hope you all might be knowing, yes or no? Here y and x are the part of the equation, and whatever the equation you will get, it will be in the form of a linear equation only. Remember this. Whenever in this chapter it says that you have to find the equation, yes or no, as your first exercise, it is based on what, equation of tangent and equation of normal. So whenever it says that you have to find the equation, remember, equation, the final answer of a tangent and of a normal, it will be in the form of linear equation. Why it will be in the linear equation? As here clearly we can see that the power of x and y is 1. Whenever the power of x and y is 1, so remember one thing, that the final answer, the final result, the equation will be in the form of linear only. Okay, so now what exactly I want to explain here, as this was the formula, it was there in 10th standard. Here just simply this m is replaced by dy by dx. So what is dy by dx here? Derivative with respect to, we used to find the derivative with respect to x, yes or no? So in simple language, the slope which we find in derivative, and m which we used to say slope in 10th standard, now actually that m and dy by dx, it is one and the same. Okay, it means what? After finding the derivative, suppose if you have an equation like this, when you find the derivative with respect to x, after substituting the value of the coordinate, whatever the coordinate it is given that a line is passing through so and so, after replacing the value of x and y, yes or no, after replacing the value of x and y, so whatever the answer here you will get in this part is the slope. So in simple language here I will say, after replacing the value of coordinate, so whatever the value you will be getting here, indirectly or directly, it is known as what? Slope only. Slope of the tangent, yes or no? The slope of the line, I can say. So in simple language I will say, m which we used to take in 10th standard, the symbol m as slope, here dy by dx, actually it is known as what? Slope here. So that is the difference here. So simply here m is replaced by what? Y minus y1 equal to dy by dx at coordinate x1 comma y1 x minus x1, that's it. Here m is replaced by what? Dy by dx. So this equation is known as what? Equation of tangent. This equation is known as what? Equation of tangent. If we replace m by dy by dx, that straight equation, that when we replace m by dy by dx, that what equation we are getting now, it is known as equation of tangent. Now what do you mean by equation of normal? Equation of normal. So what do you mean by equation of normal? Normal means perpendicular. Normal means what? Perpendicular. In mathematics language, the normal means perpendicular. Okay. So now to find the normal, before that you have to find the slope of normal. What? You have to find slope of normal. Now, for example, if I say here we got the answer of dy by dx as 2 by 3. Here we got the answer dy by dx as 2 by 3. Okay. 2 by 3. To find the slope of normal, simply what you have to do, you have to reciprocal this value with opposite symbol, or you can apply this formula. Okay, to find the slope of normal, your minus will come, remember. Okay, minus 1 upon, apply this formula, dy by dx at x1 comma y1. It means you will write minus 1 here, dy by dx here we got what? 2 by 3. Okay, this 3 will go up, so answer will be what? Minus 3 by 2. That only I had explained. Now whatever the value of dy by dx we are getting here, simply what you will do, you will reciprocal this value, you will reverse this value with the opposite symbol. When you reverse the value with the opposite symbol, when you write the number in reciprocal with opposite symbol, this slope is known as the slope for normal. Remember this. Once again I will explain here. Suppose if you are getting dy by dx after replacing the value of x1 y1 coordinate, suppose if you are getting 2 by 3 as an answer, so this slope actually it is for slope of tangent. Now suppose if you want to find the slope of normal, normal means perpendicular. Okay, if you want to find slope of normal, so what you will do, simply you have to write this number in reciprocal form. Okay, write the number in reciprocal with opposite symbol, that's it. So this slope actually is known as what? Slope of normal. Or else if you want to write, you can write this answer directly like this, or else apply the formula. The formula is minus 1 upon dy by dx x1 comma y1. It means minus 1 upon, what is dy by dx at x1 y1 is 2 by 3. Okay, bring this 3 up, so the answer will be 3 by minus 3 by 2. Okay, so can you see that this answer is 2 by 3 and this one is what, minus 3 by 2. Okay, so this answer it is for the slope of tangent and this answer it is for slope of normal. So these are the small things, small point which you have to keep in your mind while solving the sums of your first exercise. Yes or no? Okay, now the last thing which I want to explain here, the last part, very important part. In the question you will have two form of equation. One equation will be linear equation and another form will be what, sometime it will be a quadratic, sometime it will be a polynomial. Okay, now remember this, whenever you have a quadratic equation or a polynomial form. Okay, remember whenever you have a quadratic or a polynomial form, like here we have a equation of curve, as the power of the variable of x is what here, 2, so it is in the form of quadratic, it look like a quadratic. Okay, as the power of the variable is 2. If it is 3, it means we can say it is a polynomial. Okay, remember sometime what will happen in a question, you will have a linear equation also, they will give the linear equation also. Like remember, if you have a quadratic a polynomial, straight away for that equation you will find what, straight away you will find the derivative with respect to x, so and so you will get the answer. Whenever you have a linear equation, whenever you have a linear equation, okay, like suppose if I say 3x plus 2y equal to 1, so here what you will do, whether you have to find the derivative with respect to x to find dy by dx, or we can find the answer directly. Yes, here with the using the formula which was there in the 10th standard, I hope you all might be knowing, to find the slope, the formula it was minus coefficient of x upon coefficient of y. So remember this formula, this concept, it is only for when a equation is in a linear form. Whenever we have a linear equation, then only we can apply this formula. This formula it is only for the linear equation, we cannot apply this formula for quadratic or a polynomial. So for quadratic and a polynomial, like here we have a equation, we cannot apply this formula to get the answer of slope directly. Okay, so remember whenever we have a linear equation and it says that we have to find the slope, apply the formula. So here you will get what, minus coefficient of x, you have to check the coefficient of x is what, 3. What is the coefficient of y? It is 2. That's it. Here we got the answer. So remember, whenever you have a quadratic and polynomial, straight away you will derivate that particular equation to get the answer, and you have to derivate with respect to x only. Whenever you have a linear equation, apply the formula to get the answer of the slope. Don't derivate with respect to x to get the answer of dy by dx. Okay, here also you will get the same answer. When you derivate this part, yes or no, when you derivate this part, you will get the same answer only. But with the help of formula we can find the answer, as the formula it was there in the 10th standard, the slope it was minus coefficient of x upon coefficient y. Yes or no? Okay, if you don't want to apply this formula, you can stick with this method only, derivative with respect to x, as here 3x derivative will be what, 3. Yes or no? 2y derivative will be what, 2 into dy by dx, and derivative of 1 will be what, 0. So further this we can write as what, 2 into dy by dx, which will be equal to 3 will go that side, so that will be minus 3. Okay, so the final step will be what, dy by dx is equals to minus 3 by 2. Here also we are getting the same answer. So it is on you, if you want to apply the formula, with the help of formula also you will get the answer, or you derivate with respect to x, still you will get the answer. Okay, as I'm explaining this part with respect to this formula. Why? Because it was there in your lower standard. It was the formula, it was there in 10th standard. So with the help of formula also we can find our answer. So remember, this formula actually it is for only for a linear equation. Whenever we have a quadratic and polynomial, we cannot apply this formula. There is only one method to find. Dy by dx is what? Straight away derivative with respect to x. Okay, but remember, whenever you have a linear equation, apply this formula to get the answer of slope directly. Yes or no? Understood? Okay, so now I hope you all understood the concept. Okay, just remember this part. For a quadratic and polynomial, don't apply this formula to get the answer. This formula it is only for a linear equation, as we can apply the derivative concept also, but here we don't know the point in which the line is passing through which point, x1 comma y1. So that's why I told to apply the formula to get the answer directly. Okay, so now I hope you all understood the concept. These are the basic things which we will be applying in this chapter, like the derivative of x raised to n, derivative of x, derivative of y, derivative of x cube, derivative of y cube, derivative of y square. So remember, whenever you have to find derivative of y is dy by dx, y square, as y is replaced, x is replaced by y, so you have to apply the chain rule. I hope you all might be knowing the formula slope point form. It was y minus y1 equal to mx minus x1. Just your m is replaced by what? Dy by dx. And x1 y1 are the point in which from the line which pass through that point. Okay, so here m, which we used to say slope till 10th standard, here that m is replaced by dy by dx. So here m and dy by dx actually it is one and the same. So after replacing the value of x1 y1 coordinate, whatever the answer you will get, actually it is what? The answer it will be in number. Remember, dy by dx answer it will be in the form of a variable. When you find the derivative of this part, here you will get the answer in form of variable. When you replace the value of x1 y1 coordinate, the answer it will be in number. That number is the slope. Actually, this is not the slope. After replacing the coordinate, the whatever the number you are getting here, that part is the slope of tangent. So to find the slope of normal, simply what you will do, reciprocal the value. Yes or no? Reciprocal the value with and write in opposite symbol. As here, suppose if we have 2 by 3, the reciprocal will be 3 by 2 with the opposite symbol. Or else you can apply this formula. The formula is what? Minus 1 upon dy by dx, x1 comma y1. Apply, and remember your minus will come. Okay, minus, don't forget to write minus. Okay, and whenever we have a quadratic and polynomial, derivative with respect to x, and whenever we have a linear equation, apply this formula to get the answer of slope directly. I hope you all understood the basic things of this first exercise. As your first exercise, it is based on what? To find the equation of tangent and equation of normal. Okay, so now we'll see the main concept of this part. Okay, so let's begin with the concept of your first exercise. Okay, and here we have the steps which we have to follow to find the answers of equation of tangent and normal. So let's begin. Let's take one example. Okay, so please remember this basic things and the basic concept. Without knowing the basic things, you cannot able to solve the sums further. Okay, and now I will explain the steps to follow and how we can find the answer of equation of tangent and equation of normal. Without using the steps also we can find the answer, but I prefer to explain the things and the sums with respect to concept or with respect to steps, so it will be easy for you all to understand and you all to solve the sums. As for each and every concept, I had prepared the steps which you all have to follow to get the answer. Okay, so please you just simply follow this 3 4 step that is there for the first exercise. I had prepared the steps for each and every exercise. Okay, so it would be easy for us to connect with the sum, and with the help of this four easy step, you can find your answer perfectly, and when you will see the backside answer, it will be perfect. So let's begin with the first example of your first exercise.